All right, second formula that we've got, which is a slightly simpler formula than the cosine law, but it is actually harder to use. So the second one is called the sine law. And yeah, it's another formula for finding sides and angles of a non-right angled triangle. So same deal, we can't use SOHCAHTOA, we can't use Pythagorean theorem. So for this one, in the previous video, I had mentioned something of the lines that if A is bigger than B is bigger than C, then little a is bigger than little b is bigger than little c, but that it's not proportional. We can't just set up ratios. What we can actually do is set up ratios for the sine of the angles to their corresponding sides. So that will be a little bit useful for us. Yeah, it's going to help us solve for some unknowns here. What we actually get for the sine law is these three equations. So when we use it, what we're going to do is just grab the pair that we like best. We don't have to use all three at the same time. So for example, for A, what I'll do here is note that I want big A, and I've got little a, and I've got little c and big C, right? That little c opposite of the angle C. So what that tells me is to set up sine law for A and C. So I'll set up the version here. So I don't care about the b's. I just need an equation between two expressions. So I'm going to set up sine A over A equals sine C over C. Plug my things in. So sine A over 2.1 equals sine C, which will be sine of 50 over 2.0. And so I'm going to isolate sine A. You can work out the right side. I do recommend just putting the 2.1 over to the top and doing this as one big nice calculation. And so if I plug this thing into the calculator, 2.1 sine 50 divided by 2, I get 0.8043. And so as always, A is going to be the sine to the -1 of 0.8043. My calculator's annoying. Which is about 53.4 degrees. All right, and so that looks pretty good. That works out. So what I'm going to do now is, solve B. So B is going to be slightly different. I need some kind of labeling here for the other two. So I'll just call this A. This has to be C, and this will be B. And so if I set this one up, same idea. I want little c, and I have B and B, and I have angle C. So that's going to tell me to use the B and C version. But I don't really love the way it's written. I'll show you why. So I'm solving for here this little c, and it's on the bottom. So I'm going to have to flip everything. So instead of doing that, what I'm going to do is just give you a second version of the sine law. They're all just ratios. We can flip the whole thing. So A over sine A is B over sine B is C over sine C. It's the same equation. It's just taking everything to the power of -1. And then what I can do is instead use the B and C version of that one, which is just one step faster for us to solve the equation. So B over sine B is C over sine C. Plug everything in. So I'm going to get B is 10.8 over sine 30 equals c over sine 115 degrees. So I'll bring the sine 115 degrees up. Uh, 10.8 times the sine divided by sine 30. And I should be able to just plug that in the calculator and it'll give us our answer. And so I get C is 19.5, maybe I'll just do 19.6. Yeah. So 19.6. All right, I'll do a few more examples. Okay, so I'm going to do example C here. One thing I want you to notice with C before going into it is that the numbers are really, really similar to what I did in B. So we've got this 10.8 and a 10.8 opposite of the 30, opposite of the 30. And then the other two angles are 65 and 115. So those two angles have a relationship to each other. We'll get to that in a second. So I'm going to set up my C over sine C is B over sine B. And C over sine 65 is 10.8 over sine 30. So C equals 10.8 sine 65 over sine 30. And if I plug all that into my calculator, 10.8 times sine 65 divided by sine 30, I get 19.6. Very close too. So we actually get the exact same C. And that might not be, remarkable to you, but it's going to come across as actually very annoying. So what's happening here is if I had set up this triangle, if I had given the little c was 19.6 and big C is unknown and told you to solve for C, well, according to the work that we just did, there's actually two answers for it. It could be 115 degrees, or it could have been 65 degrees. And so the reason why there's two possible answers is because sine of 115 degrees equals sine of 65 degrees. And that means that if I were to do an inverse sine on the ratio that both of those two things share, it may not give me the right answer. It's not 1-to-1. So there's a little bit of a problem there. So just to kind of show you what's going on, again, I'll draw like a little graph of sine down here in the bottom where I have a little bit of space left. So if we graph sine up to 180 degrees, remember it starts in the middle and then makes its way up. Well, not like that, but symmetry. Ugh, I think I'm making it worse. So that's our sine function. It goes from 0 to 1. Now, the cosine function that I showed you before, cosine looked like this. That was 1-to-1 in this region. Sine is not 1-to-1 in between 0 and 180. And 0 and 180 is where our angles could fall. So it's not 1-to-1 here, which means that if we get a particular y value, there are two possible x's or two possible inputs that could go with that y value. And so what the inverse function does is it maps to the smaller one. And so if you want the bigger one, you have to use other skills to try to figure that out. What it does mean is that you have to be really careful when using the sine law. So for this first example here, A, I didn't even ask you to think about that. And that's because the inverse sine is going to take you between 0 and 90 degrees. And the angle that I had asked you to solve for here, if you look at this picture, I know that A is less than 90 degrees. If you know that the angle is less than 90 degrees, you don't have to worry about anything. So in that picture, that is at least assuming some amount of scale, that should be less than 90 degrees. And so I can conclude that that's going to be my answer for this one. And now we do have to be a little bit careful. In future questions, I'm going to ask you to pay attention to this.